what? I've been teaching math for too many years. 24 years. Barf. And I've got another 12 that I have to do before I can get out of here. 36 years. Anyways, in that 24 years, I've noticed that no matter how many times kids tell me that they understand how to add, subtract, multiply, and divide, when I ask them to add, subtract, multiply, and divide, what happens? They don't do it right. Jack, hit me. Pardon me? Fortunately, I have extras. Grab one. Put it in your backpack. Don't lose it. And when you get the real book, it'll be much bigger. It's easier to hold on to. Oh, and that's another thing. Yes. Wait, don't tell me. I got to remember your name, but I don't remember. Kate, no. No, Kate sits there in another class. I don't remember. Haley Campbell. See, I heard your first name and I know your last name. Same as the principal. Hit me. What do you need, Haley?
So you said like 12 years? So from 1 to 12.
What?
Like grade 1.
Oh my God, go teach grade 1? My wife teaches kindergarten. She comes home with stories. Oh, this happened in my kindergarten class today. And she's laughing about it. I'm like, oh my God, I would stab myself in the eye if that happened in my class. Now it's the other way around. I tell her what happens here and she's like, oh my God, I would stab myself in the eye if that happened in my class. So we're even. Sometimes kids poo in her class. I know, right? I don't want to deal with that. None of you poo. Well, I mean, you do, but not in class, right? But then I'll say, oh, this kid swore at me and ran out of the classroom today. And she's like, wow, that would really hurt my feelings. I'm like, So it goes both ways, right? A lot of people say I should go back and teach some middle school. They think I would be good with middle school. I don't want to teach middle school. I don't know. I assume some people do. There's like 8 middle schools in this district. Somebody must want to do it. Michael, right? No. Lance. They're right there. I know. I don't understand why a 12-year-old thinks they're hot poo. I do not get it. It makes no sense to me. Right? By the same token, I don't understand how 18-year-olds are like, I want to be treated like a kid, right? Like when you try to treat an 18-year-old like an 18-year-old, you screwed up. Deal with it. Right? I don't know. But that's not going to be any of you, right? You're all mature, ready to go out in the real world, yeah? Yeah. Right, Hunter?
I hope so.
I hope so too, because it's coming up. It's only in a year and a half. Okay. No matter how many times I ask kids to do add and subtract, they screw it up all the time. So, as you well know, we're spending the first little while relearning all the math we needed to know up to grade 10, which means since you already know it, you're all going to have an A when we start this course, right? Yeah, you are. Let's start with subtraction. Now, subtraction is the first thing that screws people up, and the reason you're screwed up by it is because it doesn't exist. It's not real, okay? So, first thing you need to know is subtraction. And again, you write as much or as little of this as you want. Subtraction is adding not negatives. Adding the opposite. That is what you're actually doing. Because, of course, and you really don't have to write this down, 7 minus 3 is really 7 plus negative 3. So, 7 minus 5 is really 7 plus negative 5. And negative 6 minus 3 is really negative 6 plus 3. Because the opposite of negative 3 is 3. And negative 2 minus 9 is really negative 2 plus negative 9. Now, you're all very intelligent people. I know you are. So, when you look at this, you see you have 7 of something, and then 5 is going away. You have negative 6 of something, and then you're adding 3. Negative 2 plus negative 9. So what is this answer? Is this answer going to be positive or negative? Positive. And what will it be? 2, because 5 is less than 7, yes? So easy. What's negative 6 plus 3? Louisa? Negative 3. And what's negative 2 plus negative 9, which screws everybody up? If I'm already negative, then I'm going more negative. What's the answer going to be? Go ahead, Cole. Negative 11. Now, you're intelligent young people. You know that I'm going to let you use your calculator all the time, aren't I? Right? But how many of you have ever hit a wrong button on your calculator? All of you need to put your hands up. How many of you have then hit equals on your calculator and have it give you an answer? All of you put your hands up. And how many of you have had that answer be totally wrong? All of you put your hands up. How many of you write that answer down on the test anyway? All of you put your hands up. Even if it makes no sense, right? And then your teacher says, why would you write that? What do you say? The calculator said so. Right? Don't do that. That's why we're doing this. So you know that the answer your calculator gives you is right. Is everybody cool? All right. There's an easy method that you should think about before you touch your calculator so you know if you're doing it correctly. And it's this. All you do is change A. So if you have A minus B, you change that to positive, and you change that to the opposite. So 6 minus 2 is really 6 plus negative 2. And you know this already. Now, what's bigger, 6 or 2? 6. So you have positive 6 and negative 2. You're going to be left with a positive number, and it's going to be 4. Now, I know that you know 6 minus 2 is 4. I know that. But I want you to know why this stuff works. Because when we get into calculator stuff and the work gets slightly more complex, I want you to be able to look at a question before you touch your calculator and see positive, negative, divided by positive. Okay, the answer has to be positive. Bloop, 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 bloop. And you get a negative answer, you wouldn't write it down, would you? Okay. What about this one? So it's going to be negative 8. Change the subtraction to positive. Change that to the opposite. What's the opposite of negative 5? Positive 5. So what's the answer? What's bigger, 8 or 5? 8. So you're going to end up with a negative number, aren't you? And what is it, Dominic? What's negative 8 plus 5? You got this. What would be 8 minus 5? 3. So what would be negative 8 plus 5? Would be negative 3. And change color again to blue. Negative 4 plus negative 7. Negative 4 plus negative 7. What's the answer going to be? It's going to be negative or positive? Has to be negative because they're both negative, and it's negative 11. Easy peasy, lemon squeezy. You can do it in your sleep. It's adding and subtracting that you've done since kindergarten. Now, here's the thing that gets to me. It bothers me. I know that you all can add and subtract. I'm aware of that. But I have people that tell me the stuff I have to teach you. And I'm going to teach this to you because they tell me I have to. On a number line, because it's not enough just to know the numbers. They want you to know why it works. So, before I go too much further, we're going to draw a line right there, and we're going to put a 0 in the middle. Now, you all had a grade 5 teacher that had a number line around the room, right? It was up at the ceiling. You all had it. Everybody had it at some point in their life. The number that's right in the middle of the number line is 0, yes? What are all the numbers over here? Louisa? Those are positive. Because we know, we reminded ourselves yesterday, we have decided in our world that positive numbers are on the right, which means, what are all these numbers? Negative. Oh, you're brilliant. So, if you subtract, it means you move to the left. Because negative, subtraction. Subtraction is just adding negative numbers, right? So we're going to be moving left. Give me a number between 1 and... Actually, you know what? You can give... No, we'll keep it small. Give me a number between 1 and 10. 5. Good. 5. Now give me another number between 1 and 10. -6. So on a number line, this is where we start at 0, because that's where we start counting from, right? How would I get to 5? Is 5 positive or negative? Is that number positive or negative? Positive. Where are positive things? Right or left of 0? Right. So we would go out here to 5. Yeah? Minus means I go left. So I got to go left 6, yes? There's 5 of it and 1 more. So my answer is -1. So easy, right? And yet, people screw up subtraction. Not any of you. You're going to be awesome. But I've been doing this a long time and kids screw it up, right? If you come to a negative sign, you must change directions. Give me a number between 1 and 10. Give me another number between 10 and 20. Negative, subtract -10. So, where do I start? 0. And where do I go? Right, how far? 2. Subtraction means I turn around and go left, yes? But then what do I hit right there? A negative, which means I change direction. So I really go 10 more this way. What's my answer? 2 and 10 equals 12. So easy, right? I know you've heard all kinds of, 2 negatives make a positive, blah, 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 blah. There's a reason your teacher had that number line around the ceiling. Everybody good? Positives go right, negatives go left. That's adding and subtracting. We've done it. Multiplying is real easy. What happens if I take a positive number and I multiply it by a positive number? What do I get? Louisa? Positive number. What's 2 times 3? 6. Positive. You're smart kids. If something happens once in math, how often does it happen? Every single time. Math doesn't mess around. It's always the same, right? No matter where you go on the planet, 2 and 3 makes 5. We don't use 2 and 3 and 5 as the words, but it means the same thing, doesn't it? 2, 3, and then you do that thing your dad used to do to make magic. Any of your dads pulled that trick on you? Did they pull quarters out of your ear? Maybe it was your grandpa that pulled quarters out of your ear. Or this one? Or this one? This is my favorite. I used to do this to my kids when they were little. I would go like this. And they thought I was really stuffing the pen into my ear. And my kids, oh my God, Dad! And then I would do the thumb one too. Because they were really little. Your dads ever pull that crap on you? Your dads must have wanted you to grow up normal. I wanted to make my kids, they had to learn. No, I'm just kidding. They didn't have to learn. But it was a funny gag thing with come on, that was funny, right? With the pencil? Right? Okay. Or this one, pencil straight, right? Then you do this, and then it's wavy, like your magic. Your dads ever pull that one on you? Or your moms or your grandpa or your great uncle? No? All my material's old. All right, you're smart kids. 2 numbers the same, I get a positive. What happens when I have 2 negatives? Math's always the same. So the answer is positive. What happens if they're different? Negative. It can only be 2 the same or 2 different, right? And every number in math has to be what? Positive or negative, yeah? Is dividing related to multiplying? Yes or no? What's 2 times 3? What's 6 divided by 3? 2. So are they related? Does math ever change? So what happens if I have positive divided by a positive? What do I get? What happens if I have negative divided by a negative? What do I get? Positive. What happens if I have positive divided by a negative? What do I get? Negative. And before you even touch your calculator, you're going to look at the question and know if it's going to be positive or negative, aren't you? Right? And then you wouldn't ever write down the wrong answer because you're like, oh, I hit the wrong button. But you wouldn't really facepalm that hard because you have young brains and you don't want to damage them. It's too late for me. Too late. Are we all good? All right, take a moment, breathe, collect yourselves. We'll be back in a minute. I got to take attendance. Oh, you guys were so good. Except Cole has written the word green on his hand in red. And I'm not sure whether he wants his hand to be green or whether he wants his hand to be red. Does anybody remember the little square things? How do I use those little square things to show 5 plus 2? Louise, what would I do? Yeah, 5 little square things. Pretend they're square. I'm too lazy. No, plus. Yeah. So am I done? Then I have 7 for an answer. What do I do for this one? What do I have to do there? Dominic, hit me. 6. Pretend they're perfect squares. I know that, but that's why we pretend, Dominic.
And then you color in 4.
You could color in 4 of them, or could you draw 4 separate ones here?
Yeah.
And then what would you do with those 2? What is that? They're gone because it's 0, isn't it?
Yes.
And gone and gone and gone. And what's left?
2.
2, yay. And how would you do this one? Okay, Haley, go. What do you do for this? No, don't.
Wow, that was fun. What a great answer.
3 shaded in ones. Remember, we're pretending they're perfect squares. And then? Another 2 shaded in ones. And then I would count. How many do I have? -5. Easy peasy lemon squeezy, right? Right?
We don't have to write this down.
No, this was practice. Okay, now we're in trouble. Because everyone is scared of fractions, right? No, this is when you all say, no, we kick fractions ass. We take fractions out back and show them what it's like. Right? Right? Right, Asher? Fractions don't push us around. We push fractions around, don't we? We're the boss of us. Let's do this thing. Can anybody explain what a fraction is? And don't say 1/2. It's division. Absolutely correct. Good job. If I draw that, how many circles did I draw? 1. Okay. What if I did that? Is it still 1 circle? It's still 1 circle, but it's been cut into how many pieces? 2, right? That's half a circle. We're pretending it's perfect, right? What if I do that? Is it still the same 1 circle?
1 and 4.
But now it's been cut into 4 pieces, yes? What if I do that?
1 and 8.
Now it's in 8 pieces. So easy, right? So if the whole circle is 1, 1, or there were 2 halves, or there were 4 fourths, or there were 8 eighths, or there were x over x. That's all 1, isn't it? What if I only wanted that much of the circle? Then how much do I have? Louisa? I have 1/8. What do we call the number on the top of a fraction? Does anybody remember the proper name for it? Because I'm only going to use proper names in math class. Asher. Oh, 50-50 shot. Asher, wait. What do we call the bottom number in a fraction? Denominator! Exactly right, Asher! The denominator is on the bottom. And what do we call the top number? The numerator, denominator. And the, I know, everybody does, numerator. Now, you're smart young people. Which of those, the numerator or the denominator, tells me how much I am going to actually get? So this is my circle. It's been cut into 8 pieces. The numerator tells you how many pieces you're getting, yes? and the denominator tells you how many pieces there are. It's that easy. Every fraction is that. Right? 1 out of 8. What if I took 2 more? Now what do I have? 3 out of 8. That's all a fraction is. Now, we've got to practice adding and subtracting because kids, even if you ask the grade 12s in this school, in pre-calculus 12, the hardest class in the school, what's the hardest thing about math? Do you know what they all say still? Fractions. And when they say fractions, they mean adding and subtracting. Fractions. Now, can you all add and subtract? Of course you can. We just proved it, right? Okay. Let me draw something for you. You don't have to write anything down. Pretend these are pizzas. Everybody agree? Okay. That pizza's cut in half, yes? So how many pieces of pizza do I have there? 2. Everybody with me? Okay. This piece I'm going to cut into 8ths. Everybody cool? All right. Now I'm going to give all my friends some pizza. Well, not all my friends, just some. I'm going to give my good friend Jack 1 piece of pizza. Everybody cool? I'm going to give my good friend Cole 1 piece of pizza. Everybody cool? And I'm going to give my good friend Dom 1 piece of pizza. Everybody cool? Okay. So, Dom, Cole, Jack. Is that fair? They all have 1 piece of pizza. Isn't it fair? Why not? Because these are different size chunks of pizza, aren't they? So I can't add 2 different size chunks, can I? So would I be allowed to add some number over another number plus another number over a different number? Can I add those? No, of course not, because we're different pieces. Does everybody understand? What do we call that? Who remembers? If you want to add fractions, what do those need to be? The same. Common denominators, right? So, if I had x over y plus a over y, what would my answer be? Are these the same? So would this be the same? So what letter would go here? Y. And what would I do with the x and the a? I would just add them or subtract them, right? So x plus a or minus a. Now, there's a trick to fixing this up. So I'm going to rewrite this x over y plus a over b. There's lots of tricks, but there's one trick that always works. The new denominator is y times b. And then we do times b there and times y there. Now, I know that all of you hate it when we use letters in math, right? But why do we use letters in math? What's the point of using a letter? How many numbers are there in the world? There's an infinite amount of numbers, right? But if math works once, doesn't it always work? Is 2 and 3 magic? 5? It is, right? So that's why we can use letters. Is everybody cool? Let's do a nice, easy couple of ones to remind you that you remember your grade 5 math. What is 1/5 plus 3/5? 4/5. Easy peasy lemon squeezy, right? Because the bottoms are the same. The pizza's been cut into 5 pieces. Asher got 1, Louisa got 3, 4/5. How much of that pizza is left for me to eat? 1/5. Are we good? You all know this. This is grade 4, yeah? Okay. What would you do with 1/2 plus 1/4? Are they the same? We got to make them the same, yeah? Now, could I do 2 times 4? I could. But there's a shortcut here, isn't there? Because 2 and 4 work together, don't they, Louisa? What should my new denominator be? Go ahead, Louisa. 4. Did I change that one? So do I change that one's buddy? No. So that stays as 1. Did I change that one? How did I change it? What did I do to make 2 4? Mariella? I multiplied by 2. If I multiplied the bottom by 2, don't I have to multiply his buddy by 2? Because they're all one thing, aren't they? So now I got 2 plus 1. Are they the same number at the bottom? Yes. What's 2 plus 1? 3/4. And I'm done. So easy. Yet kids say this is the hardest thing in math class. Is it? Grade 12s in this school say this is the hardest thing they have to do. Yeah, it is hard to remember. But it's always the same steps, isn't it, Dom? If I asked you to walk to the mall, isn't that a lot of steps? Okay, and if I asked you to walk over to Cole, isn't that less steps? Do you know how to get to Cole? Do you know how to walk to Cole? So if you did that 100 more times, would you be at the mall? You'd be close. Picking up what I'm putting down? The steps are always the same, and there's only one of them to add fractions. Let's try another one. What would you do with 3/5 plus 4/7? Oh my God, Mr. Myers, that's so hard. I didn't mean to do that. Does that look like that? Yes or no? Fraction, 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 different numbers. Right, Cole? So what did I do with the 2 denominators here? What did I do right there? So what am I going to do with these 2 denominators? Because if it works once in math, how often does it work? Every single time, right? If you learn how to do one math question, do you know how to do every math question that's the same? Yeah. So if I did y times b, what is 5 times 7? Mr. Myers, I'm not very good with my times tables. That's okay. What do you have that is good with its times tables? Your calculator. Are you allowed to use it? Sure you are. So what is 5 times 7? So I'm going to rewrite it as 35. Now, you're smart kids. The b went up there. So where's the 7 going? Up there. And what math is it doing? What did this do? X times b. So what am I doing here? Times 7. What's 3 times 7? 3 times 7 plus. And what does this 5 do? Plus 4 times 5. So I get 21 plus 4 times 5 is 20. What do I do with those numbers? 41, 35. Now, can I stop there? People are saying no. I'm going to ask again. Can I stop there? Is that the right answer? Is 20 plus 21 41? Is 5 times 7 35? So is that the right answer? Yes. How many of you have had a teacher that if you left it like that, they would mark the whole thing wrong? All of you have. I'm not that guy. Everybody understand? If you get that far into a question, I'm giving you a lot of credit for it. Is everybody picking up what I'm putting down? Now, of course, you could finish it because this is math class, yes? Should you not show me all the math that you know how to do? Of course you should. If this was phys ed and we were playing basketball and you were really good at shooting baskets, would you say, I don't want to shoot any free throws? Of course not. You would shoot the ball, yes? Same thing here. How many 35s fit into 41? 1. And how many are left over? 6 35ths. If you get to there, you get a B. If you get to there, you get the A. Does everybody understand? Never, will I say you get nothing if you show me work? Is everybody cool? All right. I want you to try one by yourself. Somebody say a number between 1 and 10.
7.
Another number between 1 and 10. 5. Plus. Give me another number between 1 and 10. 3. Another number between 1 and 10.
9.
Okay. Go. Does this look like this? That's fine. What do I do with that? Does it look exactly like this? Is it fraction, fraction with two different numbers on the bottom? So what do I do? What goes here? Look at the previous example. See if you can figure it out. What goes here? He waited patiently. Oh, I know, you're all working. Okay, I'll let you work. Not one of you can tell me what I write here. Dom. 5 times 9. Which is what? What's 5 times 9? 45. Where does that 9 go? Look at the previous example. Math is always the same. What do I do with that 9? It goes up here and becomes what? Times 9. 7 times 9 is... I don't remember my times tables, Mr. Mouse. That's okay. You're going to use your calculator. What is it? 63. What are you going to do with that 5 and that 3? Times 5 plus 3 times 5, which is 15. What's 63 plus 15? 78 over 45. 45, not 48, you moron. Done. Can you make it better? Yeah. Do I care if you do, really? No. But if you did, of course, that's 1 and 33 out of 45, which of course is 1 and 11 out of 15. And we're going to talk about that in a couple of minutes. Everybody cool? Everybody should remember how to do this. What if I gave you this? What is an option? 2 and 2/5 plus 3 and 1/4. What is something you could do with that? You have two choices of what you can do with that. Does anybody remember anything about what you could do with that? What could you do if there was only 2 plus 3? What would you do? I've done it like 17 times today with my fingers. What's 2 plus 3, kids? 5. And then you've got 2/5 and 1/4. Do you know how to do that? Have we just done it 3 times? Is it going to be exactly the same as the previous 3 times? So what do? What number goes there? 20. 5 times 4 to get 20. What number goes there? 2 times 4, because the 4 goes up there. And what number goes there? 5 goes up there. 5 times 1. What is 2 times 4? 8 plus. What is 5 times 1? What's 8 plus 5? 13 over 20. And I already had 5. So the answer is 5 and 13 over 20. This is all stuff you've done a million times. You all know how to do it. Can we let addition move forward? Are we good? What would you do if this was minus? What would have to be right here? Minus. Easy peasy, right? Everybody cool? All right. Remember I said we were going to do something with that right now? We're going to. Turn the page over. Multiplying. Now, here's what happens. Think back to grade 4. How long did your teacher spend teaching you how to add fractions? It took forever, didn't it? Grade 4, grade 5, grade 6, whenever you did it. They spent a ton of time on it, didn't they? Don't write this down. Your teacher just said, what's 1/2 plus 1/3? And a bunch of you probably said 2/5, didn't you? Because you did 1 plus 1, 2 plus 3, yes? We know that doesn't work, right? So your teacher spent days and days, weeks and weeks doing common denominators, didn't they? And then they said it's time to multiply. What is 1/3 times 2/5? And you all said, oh, you're not fooling me. I need a common denominator. Do you? No. So I don't understand why teachers do that. They spend weeks and weeks and weeks on common denominators. And then they come to multiplying, and then you're all messed up by it, right? So because you've all already been messed up like that, I'm going to write right up here in nice big letters. No common denominator with multiply. Okay? You don't need one. It's only for adding. So, A over B times, let's change the letters because it doesn't matter. All you do for multiplying is A times C over B times D. And then you simplify. You can simplify first. You can simplify in the middle. Or you can simplify last. Or you may need to do it more than once. Everybody cool? So let's start with a nice easy one. What is 2 over 3, 2/3, times 1/5? Close. That's 2 times 1 over 3 times 5, which is 2/15. Is there any simplifying to do there? No. Everybody cool? Okay. What if I gave you 4/7 times 3/8? What's that answer? You okay, Dom? Okay. You got some time to rest now, though. What's 4 times 3? 12. What's 7 times 8? I don't remember, Mr. Myers, so what do you do? Calculator, so what's the answer? 56. Is there any simplifying to do there? Yeah, because those are both even numbers, aren't they? So what can I do with 12 and 56? Divide by 2, can't I? So that would get me 6 over 28. Am I done? I can divide by 2 it again to get 3 over 14. That's simplifying at the end. Everybody cool? Now, I want to show you a shortcut. Remember, because I said you can simplify at the beginning sometimes. 4 and 8, they work together, don't they? If I divide 4 by 4, I get 1, right? And if I divide 8 by 4, I get 2, don't I? 1 times 3, 3. 7 times 2, 14. Easy peasy, right? Okay. I want you to try one. 3 sevenths times 5 ninths. You decide how you want to do it. I'll give you a hint. You can simplify this now, or you can simplify it at the end. You go. You've got it written down. I'm just going to show you both ways you could do it. Would anybody like to share their answer? Cole. 5 over 21 is absolutely correct. And there's the two ways you could do it. You could go straight across at the beginning and simplify at the end, or you could simplify at the beginning and see that 3 and 9 work together. I can divide both by 3. Is everybody good with multiplying? Okay. What's a mixed number? Anybody give me an example? It's got 3, right? We've already done a couple, haven't we, Lance? 3, we'll do it with letters. A, and then a fraction. B, C, right? Right? Do any of you know how to turn that into what we call an improper fraction? There's a couple of tricks. Well, there's only one trick, but every teacher gives it a different name. Do you remember what to do, Cole?
We multiply C and A.
Right, it's C times A, and then what do you do with B? You add B. And what's on the bottom here? What stays as C? Everybody cool? So what would 3 and 2/5 become? Right, because it's 3 times 5 plus 2 over 5, which would be 17/5. Why is this important? You must make the improper fractions to multiply. To multiply. Everybody cool? So let's practice one together, and then I'm going to shut up, and I'm going to give you 4 things to do for homework. 4 questions. That's it. You'll have time in class, so you could get it done. 3 and 2/3 times 2 and 1/4. What do you need to do with that first? Times plus. What's 3 times 3? 3 times 3. 9 plus 2. 11 over 3. And what do you need to do with this green one? What's 4 times 2? Plus 1 times 9 over 4. Now, can I do something with those two? What can I do? Divide by 3, so that's 1, isn't it? And what's this one? 3. What's 11 times 3? 33, and what's 1 times 4? 4. Could you stop there? You could. Would I give you an A for it? If you want the A, how many 4s fit into 32? 8. And how many are left over? I'm going to help you out because I want this to be done. You have 12 minutes left in class. I'm going to write 4 questions right here. Yes. 8 1/4. I'm going to write 4 questions right here, and I want you to practice them. This is your work. It's all we're getting you to do. Now, remember, we took like a 6-minute break in the middle of class, right? So the other option is I go straight through and you have more time at the end. Another thing I should tell you, normally I don't talk this long. You have more time to work in class. Everybody cool? I will never give you too much work, so much work, and then talk to the end of class and make you take home homework. You will always get time to work in class. If you waste your time in class, then what does the work become? Homework. Does everybody follow me? Okay. So these are the 4 questions I want you to try. 15/7 times 2/9, 2 2/7 plus 1/4, -3. Hey, Mr. Myers, we didn't talk about negatives. Yeah, we did. Just not with fractions, but do the rules change? No. 3 3/5 times 1 +1/8 and -3 3/5 times -2 1/9. Those are the 4 questions I want you to do for homework. Do you have time to get them done in class? Of course you do. Can you choose to relax and let your brain decompress a little and then try these later at home? Of course you can. Your choice, because you're responsible young adults. And I wish to give you that chance. Are we cool? Yeah? Go.